Hello, math students. Today we're going to be going over systems of inequalities. If you did well on the other lessons and this unit, then this should be relatively straightforward. It's mostly if you can graph lines and you can graph and you understand what a solution to a system of equations is, then a system of inequalities should be fairly straightforward. There's going to be some shading in and stuff, but I'm sure you'll get the hang of it. Just follow along, do everything I do. I know this video is long, but this is something where if you follow along and you practice, I guarantee you'll understand it. And on top of that, these things, if you really want to learn them and become good, they take practice. So please follow along and let's go ahead and get started. I'm on the tutorial, page 5, and let's go and get started with this warm-up. So remember when we talked about the system of equations? When you have the two lines and they cross in one location, basically that means that they have one solution. So this first graph has one solution. And you can see that where they cross, the point where they cross is the solution. So the lines intersect at one point, so they have one solution. You can see these two lines, they're parallel. So where do they cross? Well, they don't cross at all. So the number of solutions they have is no solution at all. And so the lines never intersect, and that's why they have no solution. These, it's kind of hard to see for this last one, but hopefully you can see that these two lines are actually on top of each other. They're essentially the same equation, or they produce the same line. So that's why they have infinite solutions, and they cross at every point, and so they have infinite solutions. Any point that satisfies one equation also satisfies the other. Okay, so let's go ahead and move along, and we're going to talk a little bit about graphing inequalities. And this takes a bit of practice, but if you understood how to graph lines before and you understand basically that, then this should be fairly straightforward. Now, when it comes to graphing, basically what you want to do is you want to get both of these equations into slope-intercept form. Now, if you remember, that's the y equals mx plus b form. That's the slope-intercept form. Now, ours won't have equals. They'll have either greater than or less than or greater than or equal to or less than or equal to. But don't worry about that. The main thing we want to do is get y by itself in both of these inequalities. Once we do that, then we can easily identify the slope, the m, and the y-intercept, the b. So let's go ahead and do that for this first inequality. X plus y is greater than 4. So my goal here is to get y by itself once again. So I'm going to go ahead and let's just rewrite the equation here. So, or inequality, I should say. X plus y is greater than 4. So what we're going to do is we're going to go ahead and subtract x on both sides of this inequality, giving us that y is greater than negative x plus 4. Okay. So now how do we graph this inequality? Well, a couple of things. One thing, you should know how to graph the line. So if this were just y equals negative x plus 4, we should be able to identify its slope and its y-intercept and graph this line. So in this case, your slope is negative 1 because your m is whatever's next to the x. So in this case, it's negative 1x. So your slope is negative 1. Your b, your y-intercept, or the point where your line crosses the y-axis, will be at whatever the b is. So in this case, at positive 4. So we should be able to graph that line at this point. However, notice this says y is greater than. So a couple of things to keep in mind. If you have a greater than or a less than symbol, what you're going to have is a dashed line. So that's one of the key things. If you have a greater than or a less than symbol, you're going to have a dashed line. If it's greater than or equal to or less than or equal to, these will have a solid line, okay? Also, if you have a greater than or equal to, so these are both have like y is greater than or y is greater than or equal to, both those situations you would shade above the line. So there's going to be shading above the line. So if this is your line, which the line could be solid or dashed, if it's a greater than, y is greater than, then you'd shade above the line. So you'd shade above that line. Whereas if it's a less than, so if it says y is less than or y is less than or equal to, then when you have your line, you would shade below. Okay, so this applies whether you have a solid or a dashed line, doesn't matter. If you have a less than or less than or equal to, you shade below. If you have a greater than or greater than or equal to, you shade above. If it's just strictly greater than or strictly less than, it's a dashed line. And if it's greater than or equal to or less than or equal to, or in other words, it has that or equal to, then it's going to be a solid line. Okay. So this is a very important concept that's going to really help you to graph these inequalities. Basically, you need to know how to do this. So I would definitely write this down on a side piece of paper and make sure you fully understand what's going on here. And we're going to practice this a lot. So even if it's not 100% clear, if you write this down, it'll make more sense as we continue on. But anyway, so let's take a look at the inequality that we just got. Y is greater than negative x plus 4. So again, our slope is -1 because it's -1x, and it has a y-intercept of +4. Okay, that's great. Now, what kind of graph are we going to have? Is it going to be a solid line or a dashed line? Well, since it's a y is greater than, this is the situation we have, we'll have a dashed line, and we're going to shade above the line. Okay, so let's go ahead and graph that. Y is greater than negative x plus 4. So let's go ahead. It's going to be a dashed line. So, and our y-intercept is +4. So at +4. And our slope is -1. So that's the same as down 1 over 1. So it'll be like this. And like we said, since it's y is greater than, we're going to shade above that line. So that's going to be over here, like top right. So a shade region, drag over here, and that should be your first inequality. Now let's go ahead and try to graph this second inequality. 2x minus y is greater than or equal to 2. This one's a little more complicated, but I'll show you exactly how to do it. So we have 2x minus y is greater than or equal to 2. Once again, you want to get y by itself. So my goal, my first step is always to get y by itself. So the first thing we're going to do is subtract 2x on both sides of the inequality. So inequalities kind of work like equalities, where whatever you do on one side, you have to do the exact same thing on the other side. So this cancels here. We have negative y is greater than or equal to, and then we have negative 2x and plus 2. We can't combine these. These are not like terms. So now when we take a look at this, instead of having just a y here, we have a negative y. So we actually need it to be positive. So what we're going to do is divide by -1 on both sides of the inequality. And whenever you multiply or divide both sides by something, you need to multiply or divide every single term, okay? Just like in equations. So this is going to be y, and then this is going to be positive 2x over here now, and this is going to say -2. So we can see our slope, our m, is 2, or in other words, 2 over 1. So rise 2, round 1. And our y-intercept is -2. So the y-intercept will be on -2 there on the y. Now, one thing to keep in mind is notice I divided everything by a negative. So one kind of trick that you need to keep in mind is that whenever you multiply or divide both sides of the inequality by a negative, that flips your inequality. So in other words, see how it was a greater than or equal to? Since we divided everything by -1, that's going to turn to a less than or equal to. So that's one key thing, is that this changed from a greater than to a less than because we divided by a negative. So anytime you divide by a negative, you're going to need to switch from a greater than to a less than, or less than to a greater than. So that switches your inequality. So here's our inequality that we need to graph. Y is less than or equal to 2x minus 2. Okay. Now, in this case, it's going to be a solid line, right? Because it has that or equal to. What was it? -2. And then -2 is our y-intercept. Then we go up 2 over 1. And once again, it was y is less than or equal to. So we're going to shade below or above. Well, in this case, shade below. Because it's less than or equal to, you shade below your line. Now, the solution set is this double shaded region. Okay, so the double shaded region of our graph is the solution set to our graph. All right, solution set to this system. What that means is that any point in this double shaded region will produce a true statement for both of these inequalities. Okay, now that's a key thing, is that anything in that double shaded region, so let's take the point 8, 2. 8, 2 will produce a true statement for these two inequalities. I'll show you what I mean. Now, this is true for any point in this double shaded region, any point in this double shaded region. I just said 8, 2, but you could choose any test point in this double shaded region. I'm just choosing 8, 2. Okay, but any point over here in this double shaded region will work. Now, what that means is that in these two inequalities, if I replace x with 8 and y with 2, it'll produce a true statement for both of these inequalities. Let me show you what I mean. So I'm going to rewrite both these inequalities using this coordinate point. I'm replacing the x with 8 and the y with 2. So that'll give us, for this first inequality, 8 plus 2 is greater than 4. Well, we can see that's true, right? 8 plus 2 is 10. 10 is greater than 4. Yes, that's a true statement, isn't it? Now, the second one should also produce a true statement. 2 times x, so it's 2 times 8, right? Because I'm replacing the x with 8, minus replace the y with 2. And we want to see, is that greater than or equal to 2? And indeed it is, right? Because 16 minus 2, right? 2 times 8 is 16. 16 minus 2 is 14. And 14 is definitely greater than or equal to 2, right? So any point in this double shaded region will produce a true statement for both inequalities. And that's how you know that it's the correct shaded region. Okay. Now, if that didn't make 100% complete sense, that's okay. Just keep following along, writing down everything I write, and I guarantee you it'll make a lot more sense. So here we have a system of inequalities. Y is greater than 2x plus 3, and then y plus 3x is less than or equal to 1. Now, what we want to do is see which of these coordinate points would be part of the solution set. So which of these coordinate points would be in the double shaded region? Well, what we can do instead of graphing is just take each point and plug them into the inequalities and see if it produces a true statement for both inequalities. So if it's in the double shaded region, that'll mean that it's in the solution set and that it would produce a true statement for both inequalities. So let's go ahead and try each of these points one by one, and we're going to plug them into the system of inequalities to see if it works. Now, again, the point has to produce a true statement for both inequalities in order to be a part of the solution set. So let's try this first one here, 0, 5. So we're going to replace the x with 0 and the y with 5. So how do we do that? So let's go ahead and rewrite this first inequality, replacing the x with 0 and the y with 5. So this will say 5 is greater than 2 times 0. Remember, 2x means 2 times x. Okay, so 2 times x, 2 times 0 is what that becomes, plus 3. So that makes 5 is greater than 0 plus 3. And that's a true statement, isn't it, right? Because 5 is greater than 3, right? 0 plus 3 is 3. So that produces a true statement there. That's good. Let's see if it produces a true statement for the other inequality. Remember, in order to be part of the solution set, it must produce a true statement for both inequalities. So I'm going to replace the y with 5, so 5 plus 3 times 0 is less than or equal to 1. So this becomes 5 plus 0 is less than or equal to 1. Then it says 5 is less than or equal to 1. Well, that's not true. That's actually false, isn't it? 5 is not less than or equal to 1. So therefore, this is not part of the solution set. Even though it worked for the first inequality, it does not work for the second inequality. So it would not be in the double shaded region if you graph them. Okay. Let's go ahead and try the next coordinate point here. So I'm going to replace again the x with -5 and the y with 5. And so what you're going to do is just try each coordinate point just like that. So replacing x and y into both inequalities to see if it works for both inequalities. So I'm going to go ahead and the first inequality, 5 is greater than 2 times negative 5 plus 3. And I can already see this is a true statement. 5 is greater than negative 10 plus 3. So 5 is greater than negative 7. Yes, that's true, isn't it? Let's check the second inequality. 5 plus 3 times negative 5 is less than or equal to 1. This looks like a true statement as well, because this is 5 minus 15. Remember, positive times a negative is negative, so that's why it's negative 15 here. And this is definitely less than or equal to 1, right? Because 5 minus 15 is negative 10, and negative 10 is definitely less than 1. So that produces a true statement for both inequalities. So this would definitely be part of the solution set. Let's check the next coordinate. So remember, there might be a lot of numbers that are part, or a lot of points, in fact, infinite points in the solution set. So in pretty much all these situations, there will be infinite points in the solution set in the double shaded region. So in fact, all of these could be in the double shaded region. We just have to check them one by one. Okay, checking the next point, replace the x with negative 1 and the y with 4. So first inequality says 4 is greater than 2 times negative 1 plus 3. 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. 4 is greater than 1. Yes, that's true. Let's go ahead and check the next inequality. So 4 plus 3 times negative 1. And we want to see, is that less than or equal to 1? 3 times negative 1 is negative 3. 4 plus negative 3 is 1. Is 1 less than or equal to 1? Well, yes, it is, because it's equal. Okay. So this produces a true statement on both. By the way, keep in mind that 1 is less than or equal to 1 is true, but if it said 1 is less than 1, this would be false. So if it has the or equal to, then they're allowed to be equal. But if it has the strictly less than or strictly greater than, then this would be a false statement. Does that make sense? Hopefully that makes sense. Okay. Hopefully you're writing all this all down. I'm going to erase some of this so that we have room for the next one. So the next one here, replace the x with 0 and the y with negative 5. So the first inequality says negative 5 is greater than 2 times 0 plus 3. Well, this is false, isn't it? Because 2 times 0 is 0. 0 plus 3 is 3. Is negative 5 greater than 3? No, that's false, isn't it? So this is not going to be in the solution set. So once you can see it doesn't work for one of them, then you don't have to check the other, because we already know it's not going to be in the solution set. So let's try the next one. Replace both x and y with negative 3. So negative 3 is greater than 2 times negative 3 plus 3. That's negative 3 is greater than 2 times negative 3 is negative 6 plus 3. Negative 3 is greater than negative 3, right? Negative 6 plus 3 is negative 3. Is this true or false? Well, hopefully you can see that that's false, right? Negative 3 is not greater than negative 3. They're equal. So that did not produce a true statement there. So our solution, only these 2 points will be part of the solution set. Now, in fact, there'll be infinite points in the solution set, but these are just 2 of them. Okay. There you go. Let's go ahead and move along in the tutorial. So let's go ahead and move along to page 19 in the tutorial, and we're going to go ahead and get started with this activity here. Gabrielle is baking large batches of brownies and cookies to share with her friends and family. Among other ingredients, her brownie recipe calls for 1 cup of sugar, 2 eggs, and her cookie recipe calls for 3 cups of sugar, 2 eggs. Gabrielle has 20 eggs and 21 cups of sugar, and she would like to know how many batches of brownies and cookies can she make without getting more ingredients. Okay, she doesn't want to go back to the store and get more sugar or more eggs. So we want to know basically using the ingredients she has, how many batches of stuff could she make, right? Well, basically we have two limiting factors, how many eggs she has and how many cups of sugar she has, right? So if we think about the 20 eggs, let's think about the brownies as X and the cookies as Y, okay? So let's think about the amount of, let's start with the eggs, I guess. The brownies call for 2 eggs. So for each batch of brownies, it's 2 eggs times the number of batches of brownies. Plus the cookies, similarly, also are 2 eggs. So 2 eggs times the number of cookie recipes. Now she only has 20 eggs. So if this is the number of eggs being used, she can only use less than or equal to 20. Okay. So she can use less than 20 because she has 20 eggs, but she can't use more than 20, right? Okay. Now let's focus on the sugar. So for the sugar, I'm going to do the second equation, different color. So for the brownies, it takes 1 cup of sugar. So 1x. So 1 cup of sugar times the number of brownie recipes plus, and for the cookies, 3 cups of sugar times the number of cookie batches. And she has 21 cups of sugar, so she could use less than or equal to 21 cups of sugar. So this is your system of inequalities here. Let's go ahead and find, looks like this is our system here. And there you go. Now what we want to do now is for the next question, we want to go ahead and graph this system of inequalities. So remember, like I said before, let's go ahead and get both of these inequalities into slope-intercept form. Again, slope-intercept form, if you don't already know, y equals mx plus b, where the m is the slope, the rise over run, and the b is the y-intercept, so where the line will cross the y-axis. Now, so for both these inequalities, we want to get y by itself. Okay. So let's go ahead. I'm going to go ahead and do the first inequality here. And I would subtract 2x both sides. So that'll give me 2y is less than or equal to negative 2x plus 20. Then go ahead and divide both sides by 2 to get y by itself. Now, in this case, I would not flip the inequality because I'm dividing by a positive. Only if you divide by a negative, then you'd flip your inequality. So this is negative 1x, or you can think of it as negative 1 over 1. So you go down 1 over 1, right? And then plus 10. So our y-intercept is 10 there. So let's go ahead and graph that inequality. So y is less than or equal to negative 1x plus 10. Now, since it was an or equal to, we would use a solid line. Our y-intercept is 10, and we go down 1 over 1. And since it was y is less than or equal to, would we shade above this line or below? Well, since it's less than or equal to, we would shaded region below. So there's your first inequality. Let's go ahead and try the second inequality. So once again, we want to get y by itself. So the first thing I'm going to go ahead and do is subtract 1x on both sides of the inequality, giving us 3y is less than or equal to negative 1x plus 21. Divide by 3 on both sides of the inequality in order to get y by itself. So that gives us that y is less than or equal to negative 1/3 x, we can call this, plus 7. So in this one's case, our slope tells us down 1 over 3, okay? And we have a y-intercept of 7. So we want a solid line once again, start the y-intercept at 7, down 1 over 3, and once again, it was less than or equal to. So once again, we're going to shade below. So now look at this double shaded region. This is our solution set. So for example, any point in this solution set is a possible number of batches she could make, right? So for example, she could make 4 batches of brownies and 2 batches of cookies. That's a possible solution, right? So which of these points are in our solution set? So what we're going to do is just see which of these coordinate points are in the double shaded region. So 8, 1, 8, 1, yes, that's definitely in the double shaded region. So we're going to click that. -1, 5, no. In this case, we can't have negatives because we can't have a negative number of batches being made. That simply doesn't make sense. 5.2, 3. Now, normally I would say, yeah, you can make 0.2 of a batch of brownies or whatever, but I think in this case, they don't want, they only want whole number amounts. So sometimes you could say decimals are fine. Sometimes you could say only whole number amounts. I think in this case, we only want whole number amounts. It'd be hard to split eggs in this way, right? Let's check the next point, 2, 7, 2, 7. That looks like it's outside the double shaded region. So we're going to say no on that one. And then 4, 5, 4, 5. Yeah, that's definitely in the double shaded region. So we're going to go ahead and click that one as well. And there you go. All right, so that was the tutorial. A couple things to just keep in mind is that the solution set is the double shaded region. If it has greater than or equal to or less than or equal to, like has that or equal to, you're going to use a solid line. If it's strictly greater than or strictly less than, it's a dashed line. And if it's a less than or equal to, shade below. If it's a greater than or equal to, shade above. Okay. And again, the double shaded region is the solution set. Okay, well, with that in mind, let's go ahead and move on to the practice, and let's go ahead and get started with this one here. You're only going to have 5 questions on your practice, but it'll be, I have 11 questions here. You'll be given 5 of these 11 questions. So if you follow along with all 11 here, then great, you'll have a much fuller understanding. But let's go ahead and start with question 1 here. Mrs. Allen, a high school math teacher, is grading quizzes and tests this weekend. She has at most 4 hours, or in other words, 240 minutes to spend grading. She would like to grade at least 60 quizzes and tests graded. Okay. On average, it takes her 3 minutes to grade each quiz and 8 minutes to grade each test. So quizzes we're going to call X, and tests we're going to call Y. Yeah. So X is the number of quizzes, Y is the number of tests. So it says she wants to finish grading at least 60. So the number of quizzes graded plus the number of tests graded, she wants it to be at least 60. So we're going to put greater than or equal to 60. Now, it seems a little confusing because it says at least 60, and I put greater than or equal to. Now, that should make, if you think about it long enough, it does make sense, right? If she's saying, I want at least 60, what that means is she wants 60 or more, right? So she wants to grade at 60 or more. That's what at least 60 means. So that's going to be the number graded she wants to be greater than or equal to 60. Okay. Now it takes her 3 minutes to grade each quiz. So we have 3 minutes times the number of quizzes. Plus it takes her 8 minutes to grade each test. So 8 minutes times the number of tests graded. And she has 240 minutes of time to grade. So this is the amount of time she has to grade. She wants to use less than or equal to 240 minutes. Okay, so this is your system of inequalities. Now your goal here is to see which of these coordinate points would be part of the solution set. So once again, it must produce a true statement for both inequalities. Now, a couple things pop out to me. I could automatically cancel out this last one, 32, 21. I know that those will not add up to be greater than or equal to 60. So I need my solution set to be greater than or equal to 60, and all these other ones will add up to be greater than or equal to 60. So, but let me just check the second inequality, right? So basically I already checked the first inequality by saying, do these add up to be greater than or equal to 60? Yes, yes, yes. Okay, now let's move on to the second inequality. So I'm going to see which of these coordinate points will fit into this second inequality. So I'm going to try this first one first. So 45, 18. replacing the x with 45, the y with 18. Okay, so this would be 3 times 45 plus 8 times, let me move my face here, 8 times 18, and I want this to be less than or equal to 240. So let's go ahead and see if this is the case. So I have my calculator available somewhere. I don't know where I put it. Oh, here it is. 3 times 45, 135. And then 8 times 18, 144. I could already see that this is going to add up. This is not going to be less than 240, is it, right? Because these add up to give me 279, and 279 is not less than or equal to 240. So we can cancel out that because it doesn't work for this inequality. Okay, so hope that sort of makes sense. Let's go ahead and try, let's try the next coordinate point. So 70, 5, again, replacing the x with 70 and the y with 5. I already know this works for the first inequality because they will add up to be greater than or equal to 60. That's good. But let's try the second inequality. So I'm replacing the x with 70 and the y with 5. So 8 times 5. And I want to see, is this less than or equal to 240 minutes? Okay, so 3 times 70, that's 210. 8 times 5 is 40. Okay, these add up to 250. 250 is not less than or equal to 240, so that's wrong. So it must be this last one here, or this one here, 55, 9. And we could go ahead and check too. Let me use a different color here. Replacing the x with 55, this would be 3 times 55 plus 8 times y, so that's 8 times the y, which is 9. And this should definitely be less than or equal to 240. So sometimes testing all these points is a bit of a pain, but it's not too bad. 165, and I hope more than anything, I hope it just makes sense. That's the main thing. 72. Is this going to be less than or equal to 240? It should be. Yeah, that adds up to 237, right? So 237 is definitely less than or equal to 240. So I know that that's the correct answer there. Let's go ahead and try this next one here. Here we just want to find the system. Todd has at most 14 dimes and nickels in his pocket. So let's see. The number of dimes, X represents the number of dimes, Y represents the number of nickels. So it says Todd has at most 14 dimes and nickels in his pocket. So the number of dimes plus the number of nickels is at most 14. That means this amount is less than or equal to 14, right? If 14 is the most, that means you could have that much or less, right? Okay. The total value is more than $1. So the total value is more than $1. Remember, for each dime, that's 10 cents. So 0.1, that's same as 10 cents, times the number of dimes, plus 5 cents for each nickel, right? So 0.05 times the number of nickels. And that's the value. The value needs to be more than $1. Okay. Looks like they multiplied by cents here. So another way to think about this is 10x plus 5y is greater than 100 cents. So they just changed it from cents, from dollars to cents, but no big deal. So that looks like it's going to be this one here, right? Okay, very good. Haiti is making fruit baskets, which include apples and bananas. The number of apples is X, bananas is Y. Apples is X, bananas is Y. To send to some of her real estate clients. She wants each basket to have at least 12 pieces of fruit. So the number of apples plus the number of bananas, she wants it to be at least 12 pieces. So the amount of fruit is greater than or equal to 12 pieces. but should weigh no more than 80 ounces. Okay. On average, each apple weighs 8 ounces and each banana weighs 7 ounces. So 5 ounces times the number of apples plus 7 ounces times the number of bananas. And she wants it to weigh no more than 80 ounces. So she wants the weight to be less than or equal to 80 ounces. Okay, so this should be your system of inequalities. Just click that one. Just click the correct one there. Okay, this is the same situation, I guess. Haiti is making fruit baskets. All right, apples, bananas. In this case, it's the same situation, right? So we're going to use the same system here, and we're going to see which of these coordinate points basically would be a solution set for this system. Greater than or equal to 12, and then 5x plus 8y, or sorry, 7y needs to be less than or equal to 80. So I could use this first inequality to hopefully eliminate some of my answers. I know I want at least 12 pieces of fruit. Okay, so if it has less than 12 pieces, I can automatically cancel it. So I can cancel this one right here, right? 8 apples, 3 bananas, that's not greater than or equal to 12, right? That's only 11. The other ones are possibilities. So we're going to go ahead and have to check each of these possibilities. We want the total weight to be less than or equal to 80. So let's go ahead and check each of these coordinate points into this second inequality to see which ones work. So for this first one, replace the x with 14 and the y with 2. So that would be 5 times 14. I'm doing this second inequality here, plus 7 times the number of bananas, which is 2. And I want to see, is that less than or equal to 80? Okay, well, 5 times 14 is 70. 7 times 2 is 14. Well, this adds up to 84, right? Is 84 less than or equal to 80? No. Let's go ahead and try this second one. 5 apples, 8 bananas. So 5 times the number of apples. So I'm replacing x with 5 in this case, plus 7 times the number of bananas, which are 8 bananas in this case. I want to see, is that less than or equal to 80? 5 times 5 is 25. 7 times 8 is 56. This adds up to 81, right? So is 81 less than or equal to 80? No, it's not. So it must be this last one here. 10 apples, 4 bananas. Let's go ahead and double check, replacing x with 10 and y with 4, giving us 5 times the number of apples, so 5 times 10, plus 7 times the number of bananas, so 7 times 4, and I want this to be less than or equal to 80. So this gives us 5 times 10 is 50, 7 times 4 is 28. This adds up to 78, which is definitely less than or equal to 80, right? So it works for both inequalities, right? They add up to be greater than or equal to 12, and also fulfilling this one, the total weight being less than or equal to 80. Let's go ahead and graph a system of inequalities here. So once again, we want to get in both of these inequalities into the slope-intercept form. So y equals mx plus b. It obviously won't be equals, but some inequality. Y is less than mx plus b, or y is greater than or equal to mx plus b, or something, right? So we want to get y by itself, is the moral of the story. So let's go ahead and with this first inequality, let's go ahead and get y by itself. So how are we going to do that? Well, notice it's 3y is greater than, by the way, I hope you're writing this all down, 2x plus 12. Let's go ahead and get y by itself. And the way we're going to do that is divide both sides by 3 on both sides of the inequality, giving us that y is greater than 2/3 x plus 4. Okay, so what's our slope in this case? Our slope is 2/3, that's the m. And what's the b? The b is plus 4. Okay, so our y-intercept is 4. Then from there, we go up 2 over 3. Up 2 over 3, because that's our slope, 2/3. That's like that. Now, in this case, will this be a solid line or a dashed line? Well, remember, since it's strictly greater than, it should be a dashed line, okay? So it should look something like this. Okay. And since it's a greater than, right, y is greater than, do we shade above this line or below? So our shaded region is going to be above, since it's y is greater than this line, okay? So shade above there. Let's go ahead and try the second inequality here. And we want to get, once again, we want to get y by itself. So how are we going to do that? Well, I would just go ahead and subtract 2x on both sides of the inequality. So give us y is less than or equal to negative 2x minus 5. Okay, so for this one's case, our slope is negative 2 over 1, so down 2 over 1. And our y-intercept is negative 5. So start with at negative 5 on the y-axis. I always start with my y-intercept. Then I go down 2 over 1, down 2 over 1, down 2 over 1. So this is like this. And in this case, it'll be a solid line because it has the or equal to. So a solid line here. And in this case, it's y is less than or equal to. So we're going to shade below because it has that less than or equal to. So the double shaded region is this region right here. Okay, so any point in this region would be part of the solution set, and it should produce a true statement for both inequalities. Which point is in the solution set? So once again, we're going to test out the points and see which ones produce a true statement for both inequalities. So let me go ahead and try this first point here, negative 4 comma 6. Replace the x with negative 4 and the y with 6. Let's go ahead and try this first inequality. So negative 4 plus 4 times 6, and I want this to be greater than 12. That gives us negative 4 plus, what's 4 times 6? That's 24. Is that going to be greater than 12? Well, yes, because this will give us 20, which is definitely greater than 12. So it works for the first inequality. Let's see if it works for the second one. So I'm going to replace again the x with negative 4 and the y with 6. So this becomes 3 times 6. Is that going to be greater than negative 4 plus 6? Well, this gives us 18. Is this going to be greater than 2? Yes, it is, right? So it produces a true statement for both inequalities. So that means that's your answer. That will be in the double shaded region if you graph these. Okay. Each fall, a horse ranch gives wagon rides. Tickets for adults are $10 each. Tickets for children are $6 each. No more than 25 people can fit in the wagon, and the ranch owners have a goal of earning a minimum of $200 on each ride. The system of inequalities. Okay, so we have a system of inequalities to represent this situation. We also have this double shaded region. We could see where the solution set is. So we want to see which of these coordinate points would be is a viable solution. So it needs to be in the solution set. But also in this context, can we have negatives? Well, we can't have a negative number of adult tickets or children's tickets. We also can't have any fractional numbers. So we can't have like 0.5 of a ticket, right? So we can automatically cancel this negative one that has a negative. We could also cancel this 17.5 comma 5. So it's one of these two solutions, and it needs to be in the double shaded region. So let me just double check. Let's just see which of these points is in the double shaded region. So first 10 comma 15, 10 comma 15, that doesn't look like it's in the double shaded region. 19 comma 6, 19 comma 6, yeah, that looks like it's in the double shaded region. So there you go. You could always double check by plugging in that coordinate point into both equations, and it should produce a true statement for both. Okay. So this is the same situation we saw earlier with Mrs. Allen, where she's grading quizzes and tests. So if you need to see how we found the equations, you could look at the very first question in this practice. But we know that the number of quizzes plus the number of tests, she wants to grade at least 60. So greater or equal to 60. And then it takes her 60 minutes, or sorry, it takes her 3 minutes to grade each quiz. So 3 times the number of quizzes graded, and 8 minutes to grade each test. So 8 minutes times the number of tests graded. And she has 240 minutes of grading time. So she wants to spend less than or equal to 240. So I want to see which of these would be the correct graph of this situation. So a couple things here. Let's go ahead and get y by itself for both of these inequalities. So for the first inequality, I would just subtract x on both sides, giving us y is greater than or equal to negative x plus 60. Okay. What about this second one? Well, in order to get y by itself, the first thing I would do is subtract 3x on both sides of the inequality. Once again, we're trying to get into the y equals mx plus b form. So we want to get y by itself. Okay, then divide both sides by 8 to get y by itself. Giving us y is less than or equal to negative 3/8 x. And then 240 divided by 8 is 30. Okay. So you can see basically all these have the same lines, don't they? The only thing where they differ is where the double shaded region is. Well, for this one, it has a greater than or equal to. So that would be shaded above. So for the one that has a y-intercept of 60, we want to shade above. So it should be above this one, right? So we can say this one's definitely wrong because they didn't shade that. Here they did, right? Above this. Okay. So that one's a maybe. I'll go ahead and put a maybe dot right here. This one, they did not shade above that line. So that's going to be a no there. Here they did shade above that line, didn't they? Right? So this one's a maybe as well. Now let's take a look at this second one. So this one should be a less than or equal to, so it should be shaded below. So on this one, it should be below this line, which they didn't do, so that's a wrong there. So it must be this one, and yeah, you could see that here's that line, they shaded it below that, and here's this line, they shaded above that, so that's correct. And you could always check by checking one of the coordinate points from this section. So any coordinate point in the double shaded region, you can plug it in and see if it works for both inequalities. So you can see like 60, 5 will work for both of these inequalities, for example. Okay. The following system of inequalities shows a relationship between two numbers where the value of x is less than the value of y, and both numbers are integers. Okay. So we have this system. Basically, we want to see which of these coordinate points would work as in the double shaded region, essentially. So -1, 5, -1, -1, 5. Okay. I would say that's in the double shaded region. Okay. X has to be less than y as well. Okay, that's true here. So I think that's right. It says both of them have to be integers, so that's one thing too. It says they both have to be integers. So if you don't know what that means that the numbers are whole numbers. They have to be whole numbers. So that automatically cancels this one because it has that -1.5. The 0.5 is not, won't be an integer. So this 1, 4.5 also is not an integer. -2, 1 is not in the double shaded region, so that's wrong as well. Okay, which system of inequalities is the following graph? Okay, so basically they give us the graph, we want to find the inequalities. So first, let's look at this vertical line. So if you recall, vertical lines are always in the form, usually x equals, and then wherever the number is. In this case, the number is at 3. So if you just wanted the equation of the line, it would be x equals 3. Now, in our case, it's a dashed line. So it's either going to be less than or greater than, right? It won't have the or equal to. So, and in this case, it's not really shaded above or below, it's shaded to the right, isn't it? So, but that to the right on the x-axis is greater than. So x is greater than 3. So needs to have x is greater than 3. So I know that these two are wrong. So it must be one of these two inequalities, one of these two systems. Now for the second inequality, are we shaded above or below on this one? Well, it's shaded above, aren't we? So that means it's going to be, should be a y is greater than or equal to. So that's this first one here. This one has y is less than or equal to, so that's not right. A local orchestra is holding a charity concert at the community center. Each adult ticket costs $12. Each child ticket costs $8. The organizers of the event hope to raise no less than $2,500, and the community center can seat up to 280 people. The graph and system of inequalities represents this situation. X represents the number of adult tickets. Y represents the number of child tickets. So we can see the system here, okay? And we can also see the graph here. So which solution is valid? Well, a couple things. We can't have negative tickets. We also can't have fractional numbers. So this one has 200.5. You can't have 0.5 of a ticket, right? But let's see which of these two coordinate points is actually in the solution set. So 180, 80. So 180, maybe around here, 80. That looks to be in the solution set. The other point, so I'm going to say that's probably the correct answer. The other option here, 100, 100, is that in the double shaded region? No, it's not. So that's wrong there. So that's it for the practice. Okay, so now for the mastery test. One thing to keep in mind is I'm only going to go over basically giving you a hint at least for each question. Some questions I'll do completely, but I expect you to know some of the knowledge at this point. And if not, you have to rewatch some of the practice. That's fine. But I have 20 questions here. You're only going to have 5 questions, but it'll be 5 of these 20 questions. So you'll be given a sample of these questions. But if you follow along, do everything I do, it'll help you out quite a bit, especially if you follow along and do all 20 with me. By the way, if you're not subscribed already, please do so. It really helps me out, and it's just a small way for you to say thanks. Okay, question 1. Quinn is building an enclosed pen in his backyard. He wants the perimeter to be no more than 50 feet. Okay, so we want the perimeter. So we have a rectangular pen, okay? And we want the perimeter to be no more than 50 feet. So that we want the perimeter to be less than or equal to 50. Okay, so that's one thing to keep in mind. He also wants the length to be at least 5 feet longer than the width. Okay, so here's the length and here's the width. Okay, so we want the length to be at least 5 feet longer than the width. So he wants the length to be greater than or equal to the width plus 5. Okay. Okay. Which combination of width and length will meet Quinn's requirements for the pen? So here's our first equation, that the length needs to be at least 5 more than the width, but also that the perimeter, it needs to be less than or equal to 50, right? No more than 50. And the way we can think about perimeter is it's the length plus the width plus the length plus the width. So instead of P here, I could put the length plus 2 times the length plus 2 times the width. Because when you count the perimeter, you add the 2 widths plus the 2 lengths. So that's 2 lengths plus 2 widths. And we want that to be no more than 50. Sorry, less than or equal to 50. Okay, so these are your 2 inequalities. So we want to see which of these are possible combinations that work. So what you can do is replace both W and L into both of these inequalities and see if it works. So let's go, I'm going to go ahead and try A for you so you could see what that looks like. So what we do is we replace the W with 7 and the L with 20. And what we're looking for is 2 true statements, a true statement from this and a true statement from that. Let's go ahead and check to see if it's a true statement for this first inequality. So that the length needs to be greater than or equal to the width plus 5. So if we use the width as 7, so W7, and L is 20, so that's 20. Is that greater than or equal to 7 plus 5? Well, yes, it is, because 20 is greater than or equal to 7 plus 5 is 12. So that produces a true statement here. So it works for this first inequality. Does it work for this second inequality? Well, let's check. 2 times the length, so 2 times, we're saying the length is 20, plus 2 times the width, we're saying the width is 7 in this for part A. And would this be less than or equal to 50? Well, let's see. 2 times 20, though that's 40, plus 2 times 7 is 14. Is that less than or equal to 50? Well, no, that doesn't work here. This is a false statement, right? Because 40 plus 14 is 54, and 54 is not less than or equal to 50. So this is a false statement. That means this is not the correct answer. So check the other 3. One of these will produce a true statement for both inequalities. Amelie is shopping for children's books and puzzle books. She wants to purchase at least 2 more children's books. So the children's books we're going to call X, and the puzzle books we're going to call Y. And she wants to purchase at least 2 more children's books than puzzle books. Okay, so if we take the number of children's books, she wants to purchase at least 2 more children's books than puzzle books. So the children's books is going to be greater than or equal to the puzzle books plus 2. Okay. But she can afford no more than 15 items total. So the other inequality is that X plus Y, the number of books she's buying, needs to be less than or equal to 15 because she can only afford 15 items or fewer, right? If X represents the number of children's books and Y represents the number of puzzle books. So again, just like the previous example, you're going to be using these coordinates X and Y to see if it works for both inequalities. Okay, here I'll try part A here, and we can see that part A actually doesn't work because if I plug it into this inequality, X I'm replacing with 4. Is 4 greater than or equal to 12 plus 2? Well, no, it's not. 4 is not greater than or equal to 14. So that's going to produce a false statement here. You're looking for which coordinates produce a true statement for both. Okay. Anita sells stuffed bunnies and puppies at the toy store. Okay. Bunnies are going to be X. The stuffed puppies are going to be Y. She sells each bunny for $8 and each puppy for $10. Okay, so based on that first piece of information, we know that the bunnies are $8 times the number of bunnies she sells, plus $10 times the number of puppies she sells. This week, Anita wants to sell more than 30 stuffed animals and needs to earn a minimum of $4.50. So this first thing I've written here has to do with how much money she's bringing in, right? $8 times the number of bunnies plus $10 times the number of puppies. And she wants to earn, this is the amount of money she's going to earn. She wants that to be greater than or equal to $4.50, right? She wants to earn at least or a minimum of $4.50. Okay, so that's your first inequality. And your second inequality has to do with the quantity of stuffed animals, right? Anita wants to sell more than 30, right? So the number of bunnies plus the number of puppies, she wants that to be more than 30. So the number of puppies sold plus the number of bunnies sold, she wants to be greater than 30, right? More than 30. So those are your two inequalities. And so that should be that. This one's very similar to the last one. Salmon is an artist and he wants to purchase frames to display his work at home. He wants to frame no fewer than 10 of his pieces, and he can spend a maximum of 225. Large frames cost 24 and medium frames cost 18. So this is a key piece of information here. We're going to have X be the number of number of large frames is X. So large frames, that's X. And the medium frames are Y. See if you can write an inequality here for this. Well, that would be $24 times the number of large frames plus $18 times the number of medium frames, Y. Well, in this case, this talks about how much value they are, right? How much they cost. So it says he can spend a maximum of 250. So he can spend, this is the amount he's spending, needs to be less than or equal to 225, right? Because that's his budget, it says, right? He can spend a maximum of 225. Now, the second inequality has to do with he wants no fewer than 10 of his pieces. So I'm going to let you try to figure out which inequality symbol would go here. Would it be a greater than, a less than, a greater than or equal to, or less than or equal to, based on the fact that he says he wants to frame no fewer than 10, okay? In this case, that's greater than or equal to, okay? So the amount he's gonna frame, he wants it to be no fewer than 10, meaning greater than 10 or equal to 10, right? It's kind of a tricky one, the way they worded that. Which point is a solution to the system of inequalities? So here we have a system of inequalities, and we could use these coordinate points to see which one of these would actually produce a true statement. Well, let's go ahead. We want it to produce a true statement for both in this case. Let's go ahead and I'll try, let's go ahead and try answer choice B. Okay, so I'm going to go ahead and give it a try, and we're going to see if it works. If it's the correct answer, it'll produce a true statement for both inequalities. So I'm going to replace the X with 2, that's the X coordinate, and replace the Y with -3 in both of these inequalities to see if it produces a true statement for both. Okay, so here, let's go ahead and rewrite this first inequality. -3 is that's what I'm replacing the Y with, is less than or equal to 1/2 times 2, and then -3. Okay, that gives us -3 is less than or equal to, what's half of 2? Well, what's half of 2? That's 1. 1 minus 3. So that gives us -3 is less than or equal to -2, right? 1 minus 3 is -2. Well, that's a true statement, isn't it? Because -3 is less than -2. Let's try the second inequality and see if that works. So again, I'm replacing the X and Y coordinates with 2 and -3, right? So let's go ahead and rewrite this one. That's going to be -3 plus 2 times 2. And we want to see, is that greater than 6? Well, that's -3 plus 4. Is that going to be greater than 6? Well, no, because this produces 1. And is 1 greater than 6? No, that's a false statement, isn't it? So it did not produce a true statement for both. So we know that this is a wrong answer. See which one of these produces the correct answer. Okay. Lucien and Blake are taking their bikes out to a nature trail in the woods. They want to be out for no more than 6 hours, and they want to travel at least 40 miles between walking and biking. Okay. So walking is going to be our X, and biking is going to be our Y. Now it says they want to be out for no more than 6 hours. So the amount of time spent walking plus the amount of time spent biking, we want no more than 6 hours, so that needs to be less than or equal to 6. Now, it also talks about their mileage, right? So they walk at a rate of 3 miles per hour and they bike at a rate of 12 miles per hour. So for walking, they do 3 miles per hour. So 3 miles per hour times the walking plus 12 miles per hour times the time they spend biking. And they want to travel at least 40 miles. So the amount that they travel, they want to be greater than or equal to 40. Okay. See which system of inequalities produces that. Okay. What you can also do is graph these on Desmos to give you a good idea. What you could also try is a test point, because all these graphs kind of look the same. They're just shaded differently, right? This one's shaded in like the top section. This one's shaded in this section. This one's shaded here. And this one's shaded in both of these. So what you can try is well, it's definitely not this one, by the way. Try a test point from each location. So you could try this test point like 6, 1 and see if it works for both inequalities. You could try a test point here. So 1, 4, for example, and see if it works for both inequalities. And you could try a test point from over here, say 4, 4, and see if it works for both inequalities. You don't have to use the point that I did, but it has to be from the shaded region if you're doing test points. Okay. You could also use Desmos. Again, Desmos is the graphing calculator I suggest. Desmos.com gives you a really great graphing calculator, and you could simply graph these and see which graph matches these. Which graph represents the solution to the system of inequalities? Okay, this one's kind of similar to the last one, but here they give you the inequalities. One thing to keep in mind is that since this is strictly y is less than negative x minus 3, that less than, remember, if it just has less than or just has greater than, this would be a dashed line. So both of these should produce dashed lines. If it's a less than or equal to or a greater than or equal to, these both produce a solid line. And if it's a less than graphs shade below, and greater than graphs shade above. So with this first one, would it be solid line or dashed line? Would it shade above or below? What about this second one? Would it be a solid line or a dashed line? Would you shade above or below? Okay, so if you could answer those things, then you should be able to graph both of these. Okay. Colton is painting a set of figurines a solid color. It takes him 15 minutes and 5 milliliters of paint to finish a small figurine. It takes him 30 minutes and 8 milliliters of paint to complete a large figurine. Colton plans to paint at least 360 minutes, and he can use a maximum of 100 liters of paint. Okay, X represents the number of completed small figures. Y represents completed large figures. So they give you the two inequalities here based on that information. You can see it here. 15x plus 30, I think that should say 30y, is greater than or equal to 360. And then 5x plus 5y is less than or equal to 100. Okay. And they give you the graph here. So which of these points is a feasible solution? Well, one thing to keep in mind is that in this situation, we can't do a negative number of figurines. It doesn't make sense for us to graph a negative number of figurines. So we can automatically cross off this as a possible solution. Also, we probably don't want to do decimals in this case. So we could probably cancel out this as a solution. And yeah, so then you could check to see which of these last two coordinate points are actually in the shaded region. It's this tiny little sliver here, right? But you could try plugging in these points into both inequalities. If it produces a true statement for both, though, that's your answer. Choose a system of inequalities that best matches the graph below. Okay, so we have this graph here. Both of these are solid lines, so I know that they'll have either greater than or equal to or less than or equal to. Okay. Let me go ahead and give you the equation for one of these lines, and perhaps you could find the equation for the other. So I'm going to go ahead and do for this blue line here. Well, remember, we could always think of it in y equals mx plus b, slope-intercept form. So we could find the slope and the y-intercept of this line. Well, the y-intercept you see here, that's where it crosses the y-axis. So in our case, the y-intercept, the b, is 1. So we know it's going to be a 1 there. And then we could look at the slope. I like to go from one point to the next point that's on the grid lines. So it's rise 1, run 3. So remember, the slope, it's the rise over run. So the rise is 1. The run is 3. So the slope of this blue line is 1/3. So it'll be like 1/3 x plus 1. And looking at the shaded region, is it shaded above or below the blue line? Well, it's shaded below the blue line. So that's going to be a less than. And since it's a solid line, it's less than or equal to. So that's the equation for, or the inequality for the blue line there. See if you can find the inequality for the red line. This one's very similar to the last one. So if you need more example, you could look at that. So one thing you could do is you could find the equations of both these lines. I'm going to help you by finding the equation for the blue line here. So what's the y-intercept? Well, the y-intercept is 2. And if we're trying to write in the slope-intercept form, y equals mx plus b, b is your y-intercept. So in our case, our y-intercept, or where the blue line crosses the y-axis, is at 2. So I know it's going to be plus 2 there. Looking at the slope, I can go from this y-intercept to the next point that's on the grid lines. Notice it's rise 1, run 2. So rise 1, run 2. So 1/2 x. And is it shaded above or below the blue line? Well, it's shaded above, so I know it's going to be greater than. And since it's a solid line, I know it's going to be greater than or equal to. So this is the equation for the blue line. See if you can find the equation for the red line, and that should give you your answer. Okay, graph the following system of inequalities. Okay, so one thing you could do is that you could look on Desmos. You can graph these quite easily on Desmos. But if you don't have access to that, one thing to keep in mind is that this one, would this be a solid line or a dotted line? Well, since it's less than or equal to, it would be a solid line. And since it's a less than, you'd shade below. What about the second one? Well, the second one would be a dashed line because it doesn't have the or equal to, and also you would shade below. Okay, so that's a couple things to keep in mind, but see if you can do both of these graphs. Both of them, one will be solid, one will be dashed, and we're going to be shading below on both. Okay, so that's something to keep in mind. And then see if you can graph them. Okay, keep in mind that for this first line, the slope is 2, right? So that's the same as rise 2, run 1. Rise 2, run 1. This one has a slope of -1, essentially. So you'd go down 1 over 1, down 1 over 1. Okay. Hopefully you know how to graph lines at this point. The graph below represents the following system of inequalities. So here we have the system and we have the graph that's represented. Notice since they are both greater than, and they don't have the or equal to, so they're both dashed lines. You can see that here. And also they're both shaded above, right? Above this line and above this line. They're both shaded above because they're both greater than. You see that there. All right, let's take a look at the question. Which point satisfies the given inequality? So we have some coordinate points here. And you could just, this is actually pretty easy when you have the graph. You could just look, is this point, so we're going to look at point A to start. Is this point in the double shaded region? right? So if the point is in the double shaded region, well, that's the solution region. So let's see, -1, 4, -1, 4. That's right here. Is that in the double shaded region? Well, no, it's not. So I know that that's wrong. Okay, check the other points to see which one's in the double shaded region. Okay, here, choose a system of inequalities that best matches the graph. Okay, here we have the red line is a dashed line and it's shaded below. Okay, see that there for the red line? What's this inequality? Well, that would be, notice if it's a straight horizontal line. Remember when you have just a horizontal line, that's usually y equals, right? Well, in this case, not equals, but y is less than, I guess I should draw this in red. Y is less than, because it's shaded below, and I know it's not less than or equal to because it's a dashed line. So y is less than 4 in this case. Okay, so that's the inequality for that one. See if you can find the inequality for this blue line. Notice its y-intercept is -4 and its slope is up 4/1. Okay, and it's shaded above and it's a solid line. Okay. All right, here we have a graph. We have a pair of inequalities and we have the graph already. Okay, you can see the shaded region is right here. So which group of ordered pairs is in the solution set? Okay, so in this one's case, you want to see the correct answer. All the points will be in the double shaded region. Okay, all the points for the correct answer, all the points will be in the double shaded region. Okay, so for example, let's check A. So you might check one of the points, -3, -2, -3, -2. That's right here. Is that in the double shaded region? Well, no. So I don't have to check the rest of the points. I know that that's wrong. So the correct answer, all the points will be in the double shaded region. Okay. All right. This one's very similar to the last one, actually. Here we have some coordinate points, and whichever one is the correct answer will be in this shaded region. Okay. So let's go ahead and see. We could check answer choice A here, -1, -6. That's right here. Is that in the shaded region? Well, clearly it's not, so I know that that's a wrong answer. So see which one of these is in the shaded region. Choose a system of inequalities that best matches the graph. Okay, so here we have a graph and we want to find the system. Okay, well, in this case, one thing to keep in mind is for the red line, it's shaded below the red line, right? And also the red line is solid. So I know that for the red line, it'll be y is less than or equal to. Notice it's less than because it's shaded below, and it has the or equal to because it's a solid line. For the blue line, notice it's a dashed line, but it's also shaded below, isn't it? It's shaded below the blue line. So that's going to be y is less than. This case, this one doesn't have the or equal to because it's a dashed line. Okay, so that's one thing to keep in mind, and see if you could find the equations of the two lines. Graph the following system of inequalities. So here we have a system, and we want to figure out which of these graphs is represented by that. Well, one thing you could do is you can graph the two graphs on Desmos and see which graph represents that. But another thing to keep in mind is that for this first line, it has y is greater than or equal to. So that means it would be a solid line. So this one has a solid line, and also it's shaded above. This one would have a solid line, but shaded below. Okay, so one graph should have shaded above, one should be shaded below. Now let's go ahead and I'll help you graph one of these. I'm going to actually help you with graphing this bottom one here. So for this one, what would that look like? So I'm going to give you a rough sketch here. Well, it would have a y-intercept of -2. So the b in this case is -2. And the slope is -4. So that's the same as -4/1. So you'd go down 4/1. So from my y-intercept, I go down 4, 1, 2, 3, 4. From here, down 4 over 1. Notice I go down in this case because it's a negative slope. In this case, it's a solid line, so I know it'll be a solid line here. And it'll be shaded below. Okay, see if you can get the graph of this top equation, and then you should have a good idea of which of these is the correct answer. This one's very similar to the last one. One thing to keep in mind is that for this bottom inequality, it says y is less than 4. So what would that look like? Well, remember when we have usually x equals or whatever, that's a vertical line. So I know this one's going to be a vertical line at 4 on the x, 2, 3, 4. And it's going to be a dashed line because it has the strictly less than. It doesn't have the or equal to. And it says x is less than 4, so that's going to be shaded to the left here. Okay, so that's one thing to keep in mind. That'll help you. And then go ahead and graph the second one. For this one, it should be a solid line, and it should be shaded below. Okay, so that's one thing to keep in mind. Use the drawing tools to graph the system of inequalities on the coordinate plane. Okay, so one thing to keep in mind is when I want to graph them, I would like for my two equations to be in the slope-intercept form. So that's the y equals mx plus b form, where b is the y-intercept and m is the slope. You can see the first inequality is already in that form, right? Because it has y by itself on the left. However, the second inequality is not in this form. It says x plus y is less than or equal to 6. So I can get it into this form by solving for y. In other words, let's get y by itself. We're going to go ahead and subtract x on both sides of this inequality. That way we can get our inequality into the slope-intercept form. So that's going to give us y is less than or equal to, and we're going to write negative x plus 6. So in this case, what's our b? Well, our b, our y-intercept, is 6. What's the m, the slope in this case? Well, see how it just has a negative here? Well, we can think of that as a negative 1. So I can put a negative 1 here. The slope for this inequality is negative 1. Or you can think of it as negative 1 over 1. So for any whole number, you could think of it as over 1. But so that should be down 1 over 1. So let's go ahead and draw this inequality to start. I know my y-intercept is 6. So on the y-axis, I put a point at 6. That's our b. That's the y-intercept. Then from there, we're going to use our slope to continue this line. So down 1 over 1. So from here, down 1 over 1. And the slope will continue in that way. Okay. And in this case, will it be a solid line or a dashed line? Well, it has the or equal to, so that's going to be a solid line. And in this case, should be shade above or below? Well, since it has a less than or equal to, that's going to be a shade below. So that's how you're going to use, that's for this second inequality. See if you can do the first inequality. Keep in mind that this slope of 2 is the same as 2 over 1. So you'd go up 2 over 1. Okay. This one's the same pretty much as the last one. We want to draw the two inequalities on the graph below. So for both of these, I want to get them in the form y equals mx plus b, the slope-intercept form. We want to get y by itself in both of these inequalities. So for this first inequality, how would I get y by itself? Well, I would divide by 3 on both sides of the inequality, giving us that y is greater than, and then we could write 2/3 x like that. So 2 over 3. It doesn't divide nicely, but that's fine. And then plus 12 divided by 3, that does divide nicely. That's 4. So this first inequality, we would rewrite it as y is greater than 2/3 x plus 4. So now we can see our y-intercept, our b, is 4, and the slope is 2/3. So you'd go up 2 over 3. Now for the second inequality, how would I get y by itself? Well, you can see to get y by itself, I need to get rid of that, this 2x. So we're going to go ahead and subtract 2x on both sides of the inequality. So that's going to be y is less than or equal to, I'm going to go ahead and put the negative 2x first, and then we have a minus 5. The negative 2 is our slope, that's the m, and the b, the y-intercept, is negative 5. We could think of the slope as negative 2 over 1. So how would you graph that? You would start at negative 5 on the y, then from there you'd go down 2 over 1. Okay, so this one has a negative slope, so it'd be going downwards as you go from left to right. Now for this top one, do you think you'd shade above or below? Well, you'd shade above because it's a greater than. And would it be a solid line or a dashed line? Well, a dashed line in this case, because it's strictly greater than, doesn't have the or equal to. Whereas the bottom equation, it has the less than or equal to. So would you shade above or below that line? Well, below. And would it, since it has the or equal to, would it be a solid line or a dashed line? A solid line in this case. Okay, so hopefully that helped you through the mastery test and the rest of this lesson. If you have any questions, leave them in the comments below. I'm happy to help in any way I can. And by the way, like, comment, subscribe, do all that sort of stuff. It really helps me out. And with that, I'll see you guys next time. Take care.